Hello, this is Ben with SmplBox. Today we're going to be building an S1 endpoint. This is a fully 3D printed enclosure. It's designed for Raspberry Pis or other single board computers. You might get some Odroid boards in here. You might get some Banana Pi, some Orange Pi boards, and you could use all those in the same case. You would just have to reprint a couple parts, and those are openly available. Alright, so we're going to start pulling out the parts. We're going to start with the sides. This is a one-piece print. It should be pretty simple. It's just a vertical side, so pretty much any printer should be able to print this. We have a top, which is again a very simple flat print. Any printer should be able to print that. And again, a bottom, another very simple flat print with some holes in it. But again, these are very vertical printing designs. You're not going to run into any issues. Fan plate, I/O plate, both very vertical and very easily printed pieces. And we have an I/O panel hold, and this is another board. I'll go over that later on what this does. We're going to add some 40mm fans, and lastly we're going to go over the screws, nuts, bits and bobs. So first we're going to start with some heat set rivets, which are 4mm. I'll put the link to the site with the measurements in the comments. Then we have the 4mm pan head cross. You would call that a Phillips screw. Now we have some standoffs. These would be 2.5mm standoffs. These will be holding the Pi or the Odroid to the board. Then we have our 2.5mm shorter standoffs. These are designed to allow you to have a shorter board in the case. Then we're going to go on with our 2.5mm screws and washers, and these are going to be used to help attach the Pi and other I/O boards to the case. Alright, and then lastly we have two Phillips head screw sets. These come with the fan, and this will also be in the description, but basically it's the attachment screws. And lastly, we have a soldering iron and some pliers. And let's get started with the build. For the first part of the build, we're going to be putting heat set inserts into the side panel. This is going to be done by heating the inserts up with the soldering iron, pressing them into the holes, and then letting them cool. This is a pretty straightforward process, but if you haven't done it before, there are some intricacies to it. You may get a little bit of plastic damage because you may overheat the rivets. I highly suggest you use a pair of pliers that you'll see here in the background to hold the rivet in place so that you can put a good force on the rivet, push it into the right position without it flipping off onto something else. Because again, the rivet will be hot after you heat it, a couple hundred degrees. I'd highly suggest you don't try to pick that up with your hands or let it really go anywhere other than into the plastic. So as we go through this, it'll probably be more apparent. So you'll see in the background, I am pushing the rivet into the plastic, and I'm not trying to even it out right away. I might pull off a little bit, take my soldering iron off the rivet, go back, try to level it out. This is so that I don't overheat the rivet. If I overheat the rivet, I'm going to have a lot of extra excess plastic melt, and that may actually go into the rivet threading, or it may just mean that the rivet hole can't be centered because I melted all the plastic around the hole. So you'll see again, I'll go through all these. Some of them will start with me going in at an angle, just because I'm trying to put enough pressure on, and one part melts and another part doesn't. So as you get used to this, you'll start getting better at it. But if you feel like there's in any shape, form, or fashion an issue with the actual build, or like inserting the heated insert into the build, pull the soldering iron off the rivet and give it some time to cool off, and then make some calculated turns after that. This is not a quick process. If you try to make this a quick process, it may produce bad results, and you may just ruin the part. The next part of the build is the standoff and screw inserts into the bottom plate. This is pretty simple. You're going to be putting the screw through the holes on the bottom plate, holding it in with your index or maybe pointer finger, and then screwing the standoff onto it on the other side. The side the screw goes on is the riveted side. It's the one with all the wavy supports, and the flat side is the one that you're going to put the standoffs on. You'll see in the background that I'll put the screw through the hole, hold it with my index finger, and then flip it over, holding the index finger firmly in the screw tip, and then putting the standoff on. I kind of put the standoff on at a slight angle, trying to put a little extra pressure on the threads. That means it's a lot easier for me to hold the screw in place, and then also put the threaded standoff on the screw. The next part is putting the standoffs for the small side panel. This is what I would call a tie-down panel. This is for putting any USB devices inside the case that you want, putting cables through and tying the cables down. Basically, this is for anchoring any internal devices to the case so that you don't have any cable pull out or damage to the internal board. Now, this is again going to be the shorter panel, rather the shorter standoffs, because the paneling on the inside will be in line with the USB ports and IO ports if you don't. And if you don't make it shorter, you're never going to be able to plug anything in on the inside. So that'll be very important. The next part is attaching the fans to the side of the case. This is important because you won't be able to access some of the screw holes for the fans if you put the bottom side on first. You'll see here I'm just trying to make sure everything matches up and all the screw holes are going to work with the build. You'll want to make sure you actually have the right size fans for the sides. These will be 40mm fans. You'll be able to, I think, only use 10mm deep fans. The fan cover, as you see coming up here, will be put on first. The screw will go through that, go through the side panel, and then into the fan. Here you'll see me putting a Raspberry Pi, or rather a mock Raspberry Pi, onto the bottom board. This is pretty straightforward. Just put it on the original standoffs. You would see the larger ones. There's obviously one that's smaller square and the larger square. Make sure you put it on the larger square. I'll also put on a nut on it. I normally put a nut on all four corners, but here I'm just going to show you that it's able to be done, and then I'll leave you do it on all four corners on yours. And then I will also be putting the IO zip tie board, or I don't know what I'd actually call this. It's just really a peripheral board so that you can zip tie cables or maybe USB devices inside the case. You can also see that there's an additional 8 screw hole sets. This is if you want to build your own standoff board and you want to attach something specific. I gave you some extra IO holes so that you can put screws and standoffs to those at your own leisure. And now we're going to attach the sides to the bottom. We're going to have to also make sure that the cables from the fan, and if you use different types of fans, you could orient them however you'd like. Next, we're going to flip the bottom over and put it on top of the sides so that we can attach the bottom. It's a pretty straightforward process. You're going to want to make sure that the Raspberry Pi is facing towards the opening or the missing side of the side panel, so that you can put the IO panel there and plug all your cables in. If you orient it otherwise, you're going to run into issues because you won't be able to plug anything into your Raspberry Pi or single board computer. You'll see that these are pan head, it looks like. I think that's the right word. Screws. These are Phillips head screws. You could use hex or octagon, but I feel like it's easier to use Phillips head because most people have a Phillips head screwdriver. The bottom panel has holes that are technically bigger than the inside thread of the screw. This is so that if you had mis-soldered or misheated the heat set inserts into the sides, it's a little bit forgiving there. You're not fully penalized if you get it a little bit off. Alright, now that we have all of the screws on the bottom, we're going to flip it over, and you can attach fans here if you'd like. Do any cabling you want, because the next steps are pretty straightforward, and it's just closing up the case. Alright, now that you've put the bottom on, we're going to flip it over and we're going to put the IO panel in. And at this point in time, you should run any cables or put any Raspberry Pi hats or SBC hats on that you'd like. put any USB devices inside. If you have a USB SSD or anything like that, any temperature sensors that you'd like to use, go ahead and put that on the inside, and zip tie it down. Take all the cables that are coming outside of the HDMI cables, the audio cable, the USB power cables. Make sure you take all those and zip tie them to the T on the board on the left of the Pi. This is really important, so it keeps these cables from being pulled out or damage the ports on the inside. So you just run them along that T and then just zip tie the cables to that T. As you can see, that there's a little bit of friction here with this design. This is just a part of the Raspberry Pi dummy board that it has a little bit of extra tolerance in there that I could take out in the next version. So your Raspberry Pi should be fine. You can also see that my Raspberry Pi, I think, is a 4, but this I/O panel is for a 3. Again, I put versions for 1, 2, 3, and 4 in the STL files, so you'll be able to download and print whatever version you'd like. And then you'll see after you put all the cables in, I'm just screwing down the top, and you're pretty much done. You've installed the fans, you've wired everything, you've set up whatever you're going to use the Raspberry Pi for, and after this, you have a fully functioning device. So, and you can see here, I'm stacking 2 of them together, and you can see that these fit very well together. They all have good tolerances. And it's a pretty tight fit. You can stack as many of these as you'd like. They're all heavy duty, and there shouldn't be any issues. So yeah, we're done. I hope you guys enjoyed the video. I hope you guys will enjoy the print. If you have any comments or questions, you can leave them on the site or in the comments down below. And yeah, you guys have a great day.